All right, you think you got it? Let's find out. Reviewing, describing, and analyzing TCP and UDP communication. Number 1. The TCP three-way handshake is a process of using blank and blank messages to exchange sequence numbers. What do you think? Answer B. SYN and ACK. TCP three-way handshake is SYN, SYN-ACK, ACK, back and forth, which allows it to exchange sequence numbers and acknowledgement numbers, so that as the further communication happens, they can tell if a data segment was lost and retransmit it reliably. Question 2. What element in the TCP header allows TCP to send data in window sizes far beyond what was originally designed in the TCP protocol specification? Answer C. Window size scaling factor. The original TCP specification had a window size of around 65,536. Not that I've seen that number a number of times, because back in the day, nobody could imagine that a number would or window size would be reliable beyond that because our networks were so choppy back then. Well, nowadays they said, well, let's take that and multiply it by a hugely large value to give window sizes that allow a stream of communication to be sent for a single acknowledgement, allowing our efficiency to go through the roof. Question 3. Which of the following is a graceful way of closing a TCP session? Answer is C. There's actually 2 graceful ways of doing things in here: the push and the fin. The push pushes a segment of data up to be processed in the TCP stack. However, a fin is the one that actually closes the session gracefully. I'm done. Let's go ahead and close this down. A reset means something went wrong or something timed out and it forcefully reset the session. And last one, question 4. Because it's unreliable, the UDP header includes a type of sequence number that allows the receiving end to reassemble packets that may be out of order. True or false? The answer is false. UDP is unreliable, and in that is that there is no sequence number whatsoever. So UDP sends data and hopes it gets there. If you want something to go back in order, you need something else up at the application layer that tags on little sequence numbers onto it that helps it do that. An example of that would be the RTP protocol, real-time, I can't even say it, real-time transport protocol. It's used for voice over IP because sometimes voice over IP conversations end up a little out of sync because of the multi-path nature of networks. So it adds its own little sequence number up inside the header, supplementing UDP's base functionality so that it can be put back in order. However, that's beyond the base UDP functionality. Well, that's it. The foundation of TCP and UDP, and seeing that through the eyes of Wireshark. I hope this has been informative for you, and I'd like to thank you for viewing.